Hello and welcome to part 3 of lecture 5 of ENGR 231 Engineering Statics. In this part of the lecture, I'm just going to introduce cross products, and then in part 4 we're going to look at how we can apply those to moments. So many of you have probably seen cross products before, but I thought I would just do a very brief introduction to what they are, and in case it's been a while since students have seen this topic, this mathematical operation, etc. If you already are very familiar with cross products and this is going to put you to sleep, go ahead and skip over to part 4. But I'll go ahead and describe this here. So cross or vector products are the second main form of vector multiplication. The first is the dot product, which you've already discussed, and it is often called the scalar product because the result is a scalar. It's just a magnitude. But the vector product or the cross product produces something that is a vector. Okay, so let's see here. Now, the first thing I'm going to describe, so first of all, let's say we have vector A and we have vector B. And vector A has components AX, AY, and AZ. And vector B has components BX, BY, BZ. BX, BY, BZ. Now, I'm going to run through the formula first. So, A cross B. I'm going to run through the formula fairly straight, first of all, and then we'll discuss some of the implications of it. So, what I like to do is I always just go and write my numbers, or my, in this case I'll do it in variables, but if I write them out as a little mini matrix, AX, AY, AZ, and I'm going to kind of go through the classic way of finding this. So there are going to be three terms. There are three components, the X, Y, and Z. And what I always do is I always just give myself a lot of room to write. And I just remember that the Y is, we just tack on a negative here. Now, if you start taking cross products of more complex vectors, then you have to start using more elaborate formulas. But for this class, this is not a class on matrix methods. This is not a linear algebra class. So as long as you can take the cross product of 3D vectors or 2D vectors, that's all that's required for this class. So I just think of it like this. I always have a bracket for my, or parentheses for my I, a parentheses for my J, and my parentheses for my K, and I just remember that I need to tack on a negative here. Now, if you remember how to do this, when you work, it's basically a method of covering. And this would work a lot better if I had a whiteboard and I can actually place my hand over these. But imagine placing your hand over the X column, and then the I term is based off of everything that you haven't covered up, and it's always down and to the right minus up and to the right. So in other words, here it would be AY times BZ, AY times BZ minus BY times AZ. And you're just multiplying components. So that would be for the I. Then for the Y, we cover up the central column, and it's going to be this diagonal minus this diagonal. So that's AX times BZ, AX times BZ, minus BX times AZ. And again, this is one of those things that I really encourage you to know the method, because you could try to memorize this entire formula, but honestly that's a very inefficient use of your time and not really worth it. Then the Z, the K term, oh, I need a K hat, not just a K. So if I cover up this column and just look at just these, this is AX times BY minus BX times AY. AX times BY minus BX times AY. Okay, and that's the basic formula for a cross product. I don't know if I want to work through an example of it, because we're going to work through plenty of examples in part 4 where we look at finding moments about points. But what I would like to talk about is some basic properties of it. Properties of a cross product, of cross products. And there are two important ones that I will mention. I want to talk about, one, its magnitude, and two, its direction. So let's say we have vector A and we have vector B. We have a vector A, and that's a very crooked arrow, a vector B. So two vectors that we've positioned so that their tails line up. Now, imagine if I were to make a parallelogram with these. So just like we do with vector sums, I would have B here, and then A there, and this is poorly rendered parallelogram. Let me actually, let me go ahead and move these to their respective sides, so they're not at the corners, and that's a little confusing where they apply to. Oh, actually that should be A, and the other one should be B. B and A. Of course, we can remember. If you remember from our discussion of vector summation, when we add, we can just either do B to A or B to A. Now, the magnitude, geometrically, the magnitude of the cross product is equal to the area of this parallelogram. And you could read more about this in a math textbook or even Wikipedia or something like that, but you got to be careful what you read on there. So the area of the parallelogram is equal to the magnitude of the cross product. The magnitude of the cross product. Again, the cross product does not have just a single size, but if you did a magnitude calculation on the cross product, it would equal the area of that. And the cross product will be perpendicular to the two vectors. Its direction will usually be like into the page or out of the page, something like that. Either into or out of. Actually, I guess out of and into, but the key to it's also going to be perpendicular. The cross product, the direction, will always be perpendicular to the axes, or to the vectors that you have crossed. And in terms of what direction it is, though, it does obey the right-hand rule. So, for example, if you position one vector along coming out of, if you hold your finger, you basically hold your finger and your fingers in a straight line. And here is where I'm going to completely embarrass myself and draw the worst rendering of human anatomy ever done. Here is my incredibly poorly rendered human hand. Oh my god, this is awful. Looks like a turkey or something. The finger lengths aren't even right. Oh my god, this is horrifying. That is a human hand. Wow. Well, this is a horror show, but okay. So, let's say we have, if you can forgive my poor art skills, if you have vector A, so imagine straightening your fingers out forward, just basically straighten all your fingers out to their maximum extent. If vector A is along your thumb, and vector B is radiating out from your fingers, then whichever direction your palm is pointing, imagine taking an arrow out of your palm. So you had your palm, and then imagine a vector normal to your palm coming out of your palm, like you're pushing it or something. That would be your, that would basically be your cross product. Again, comes out of your palm. Okay, anyway, that's the basic idea of the cross product. I just want to provide this as a very brief introduction, and we will be applying this when we look at the, in part 4, when we look at finding the moment of a force about a point in 3 dimensions using cross products. All right, that'll do it for now. I will see you soon in part 4, and thank you.